thumbs up. So we're live online now, and we have people watching from all over the world right now. We're broadcasting this event in high definition with audio. It's moderated, so if you have comments or questions, please post them online on some of the various forums that we're moderating, as well as the chat room that we set up on our live webcast. Okay. And, well, this is a very big year for us at the Shootout because this is actually our anniversary of our 10th consecutive television shootout event, 10 years. And so I would say about a decade ago, actually much further back than that, I've had an interest in finding out for myself who makes the best TV each year. I'm in the TV business, I'm a specialist, I'm a professional, and I just wanted to know, for my own information, who makes the world's best TV. So I would buy them all, and I would line them up, and I would do my best by reading settings from CNET and all of that, and put them in, and I would do my own evaluation to eye. 10 years ago, in 2004, we hired Greg Lowen, who came to me, and we professionally calibrated the panels, and we looked at them very critically. And let's see, where's my slide presentation? Leanne or somebody, would you help me get that up, please? A moment here, guys. We're going to find that in one of my pockets, and then we'll be able to follow along. Thanks for the quiet pause as my glasses fell down behind the furniture. And where's my slide presentation? The slides basically show 10 years of us doing this as an event. So we called it, we had to come up with a name for it, we called it the Value Electronics Flat Panel HDTV Evaluation Event. Kind of long and worked very, very well for what we were doing. But to move along with the times, and things being Ultra HD today, 4 times the resolution, TVs being curved as well as flat, we've sort of shortened the name to be the Television Shootout Evaluation, and we've copyrighted those words. So if someone thinks they want to do an event like this, please come up with your own creative names. Don't use one that I came up with. I own the rights to that name. Here you go, Wendy. And of course, you can pay a license fee to us to use it. And so that's how we've now ascended to our new name. Let's see, so that kind of explains, because we always looked at the best TVs each year, that sort of explains why we have a $120,000 TV. When we created this 10 years ago, we never thought there would be a TV that would be in a price range of that. But the rules exist. The world's premium flagship TVs from every major manufacturer. This year, Samsung, as they've done in many years, want to prove that they can build such fine TVs, and they went ahead and designed the full array direct lit, backlit S9 series. We actually have that in our stock in a 40-inch, and we're looking at a widescreen 21:9 CinemaScope in a 105-inch, and they make that in various sizes in 16:9. All the way down to the smallest one, the 40-inch at $40,000 retail. So we just thought it would be a real wow factor to show you something that only industry insiders can see at a Consumer Electronics Trade Convention in Las Vegas. We figured how nice to bring out the big guns and show everybody in the public. In fact, this is the first public showing of this television at an event like this.
The first public showing of its calibrated. Did not have it calibrated at CES.
Well, I don't call CES a public event because it's to the trade only.
Right, but no public event except for this one has ever had one.
Right.
Calibrated.
And this is not the first time that we were the first. We were the first to show, the world's first premiere, to show the ZT60 last year. Panasonic ZT60. We had it several weeks, production units, mass production units, prior to other retailers. We're also the world's first to premiere and show LG's second generation coming out in the next few weeks. So we're doing a lot of firsts here. And that first, pardon me?
It's an OLED.
It's an OLED, OLED, organic light emitting diode. The only reason the OLED, the two OLEDs are not displaying an image, as long as the F8500 is, because this is 4K content right now, and they're limited to the old school 1080p. So we are the first again to showcase what will be coming out, premiered at Best Buy actually on August 24th, I believe. And here's a sample of it that was provided by LG. So we have broken our rules twice by taking samples from the manufacturer. Once from Panasonic last year, the first time we broke the rules. The second time we did it this year was with LG. I think everybody would agree it's worthy to be flexible, to break the rules, and thank goodness we don't have a large corporation. Please go ahead.
I just want to point out, although we did provide it with a mass production unit,
Yes,
not an engineering
that's right. We have never and will never break that rule. This is mass production. That means it's the same piece that you would go and buy and own yourself. So mass production. So it's got a serial number on it and all those types of things that go along with real, true mass production. They just took the very first units off the line and flew them in. So that's why we're just a couple of weeks ahead of the rest of the world. Let's see. Without my glasses, what do my notes say? So on this wall, which includes that wall, these are the finalists. These are the TVs that either have passed our evaluation or have become available right now in the 2014-2015 flagship premium product lines. Again, that explains why it's a $120,000 TV here. TVs on this wall range from the low 3,000s, so $3,100 at the full price over here, $3,499 over here. So there's a lot of TVs in the general public's reach, and they still qualify as premium flagship world's best televisions. Let's see what I'm up to. I was going to go through all the prices. There are some very aggressive promotions on right now from the manufacturers primarily, and we'll go through some of those promotions towards the end, because it's not really a promotion event, although it is solely sponsored by Value Electronics. We take no funding of any kind from anybody anywhere. There's no sponsorships, there's no co-op, there's no nothing. This is all funded independently. This is a grassroots evaluation, and we take guidance from the manufacturers, but we take no funds of any kind. Let's see. Once my slides come up, I'm supposed to follow them. And the agenda will come up as well. And this is without glasses for a 65-year-old senior here. So I wanted to tell you what your job is today. You're not paid. I'm not paid, really. This is it. Your job today is to have a lot of fun and to really enjoy this. We have a unique camaraderie together. We're all passionate for this industry or work in this industry, maybe with the exception of Lauren, who came here to report locally for the Hamlet. She's typing away. The Hamlet, right?
Oh, sorry, Hamlet Hub.
Yes, thank you. Hamlet Hub, yes, thank you. Thanks for coming with us. And other than that, we have a lot of press coming from consumer and trade publications as well. So your job is to have a lot of fun here today. Have great food and have great conversations, meet some of the very famous people we've brought in here today. Your job is to, most important job, is to help us pick the winner. So this is a very serious job. I want you to leave all the biases home. Oh, I once bought an XYZ brand and it didn't work right. Doesn't matter. Just look at the picture quality and judge by that only. This is a very important event, and we're relying on you to be objective. This is an objective. This is not anything that has anything to do with your personal feelings at all. So a very objective picture quality event. And to that, we have asked this year for the manufacturers to provide engineering presenters that can speak technically about product advancements in picture quality, how they relate to picture quality. So you're not going to hear much about smart TV interfaces and 3D TV. We're not going to be talking about that. We're going to talk about the advancement of television. We're also going to talk about, thanks to having Joe Kane with us today, how he is crafting the standards for the television industry to transmit and create this content for us, because it's changing now to become 4K. We're graduating there. Let's see. So you guys are the judges. You're going to pick the new king of television for 2014. Let's see. I'm going to go through the televisions real quickly. I'll do it without my cheat sheet. We'll see how we do. Let's start over here. This is Samsung's 78-inch HU9000. It's an Ultra HD TV. Ultra HD meaning it's a 4K TV, pretty commonly said. Or it's also called 2160p, which I also like calling it that. So this is the new technology that's coming out. This has a very gentle curve to it. It's the new sort of trend in television on high-end TV. To its left, and right behind me here, is Sony's 79-inch, 1 inch larger, X900B, and Ultra HD as well. It's one down from the top of their line, which is in the corner. I'm skipping over here, and that's the X950B, which is a Samsung full-array direct-lit television. That's a Sony. Right, another S manufacturer. Yeah. And that's an 85-inch model as well. There's an 85-inch Samsung, and that is a Samsung, HU8550, which is one of the price leaders in its size. It's also a direct-lit television. The rest of the series in smaller sizes are edge-lit, and it is a retail of $10,000. Retail of $25,000, retail of $120,000, retail of $3,500, which is LG's Oled, 55 EC 9300. And everybody has this layout diagram. I have one too, along with all the model numbers in a schematic diagram. We have another OLED here. We have Samsung's OLED, which is based on the RGB strip versus the WRGB that LG is using. And that is a 55 KN55 S9, C for curve. We have last year's champion, and there is no successor to it this year. So it is current in this year, and it is Samsung's 64-inch flagship plasma, the PN64 F8500. So that was last year's winner. And let's see, I guess my slides aren't coming up. So I'm going to tell you one more thing before we move on. And that is that we're going to try to make it a little bit more efficient tonight. So we're going to have some sort of a limit. You're going to be voting on the attributes. To really, on a lot of the attributes, because a lot of these are LCDs and off access is not as good, to accurately do it, we're going to ask you to line up here kind of in a single file, organized, and looking straight on each TV, voting on that particular attribute that requires a direct view. So we're going to ask you to line up during that. And again, minimal conversations, and we're going to maybe allocate around 5 minutes or so based on how it's coming along. So 1 minute before time is up, the presenter is going to raise his hand just to get your attention and tell you 1 minute left, finish up your evaluations. With all that said, I'm kind of finished with this. This has been my lifetime passion and hobby since I'm the littlest kid you ever saw. And it's always been a lot of fun for me. Cinematography, photography, storytelling, love all that stuff. I love bringing out the emotion, the fear in a scary part of a movie. I love the romance where I feel romantic and fall in love. And I certainly love all the drama and action. And I try to recreate what the directors put into the film, what the actors put into the film, exactly as if you were on the set with them, seeing it live. So it's a lot of fun recreating that from a visual and audio point of view, and that's my passion and mission in life, and I create that for our customers every day. So it's a lot of fun having an ability to do that. I have a fun career. So let's see, I think what we're going to do is, first of all, obviously, again, thank everybody so much for taking out your Sunday to join us here to select the king of television, and everybody online watching. I want to truly thank my family, of course, who have worked tirelessly and have put up with me. And I want to thank our staff at Value Electronics who have put all of this together behind the scenes. And certainly thank our presenters and manufacturers and Joe Kane and Dr. Larry Weber for being with us today. We'll do a brief bio real quickly. Everybody knows who Joe Kane is. I never had to introduce somebody who didn't need any introduction. You can always Google any of these people. Real quick, we have Dr. Larry Weber. I would say most people would say he is the major force behind the development of commercial plasma television. We have Kevin Miller. Kevin Miller is a founder of and partner of ISF TV. He's the charter member of ISF, Image Science Foundation, and he is a actual level 1 and level 2 instructor. So if you took the class, he might be signing your certificate along with Joel Silver. Sure.
I'm president and owner of ISF TV, that's my
Right.
not a partner. So,
Okay.
my wife is a partner. So actually, I'm sorry, you're correct.
I'm glad you corrected that because you're going home tonight. I'm going to go into that. You want me to do that, or you want to do it? Okay. Also, all of our panel are very top professional calibrators. They also are highly sought after consultants to the major manufacturers. These guys are hired by the major manufacturers. This is a very unique group, and I looked far and wide to find people as far away as in Europe and South Carolina and New York. These guys work, Kevin works for many years for Epson, designing their color management systems and all about their picture quality. He works with Samsung, has worked for Vizio, let's see, missing a few companies. Sharp Electronics, he's a consultant to the industry and is looking for more consulting work, as and also Kevin works in post-production and broadcasting, so he's not just in the consumer end of the business. He's been doing this Shootout with us for 7 out of our 10 years. So has Dwayne Davis, 7 consecutive years. And from Europe, David McKenzie, this is your third or fourth? Third year. Right. So I think I said enough to get things started here. I'm going to ask Joe Kane to come up and give us his presentation. Thank you, Joe.
Thank you very much. Thank you, Robert. What I'm going to be talking about today is the ultra-high definition television system as I think it should be. I'm calling it the ultimate UHD television system. UHD, if you've taken the time to listen and read articles, it originally started as resolution. And then there were a number of people who said resolution wasn't enough. And so more, better, faster pixels became one of the mantras in the industry. In other words, the UHD system was going to offer a lot more to the consumer than just high resolution. So it has evolved into a discussion of what it is actually going to be. So today I want to present a little bit of information about where some of us in Hollywood see the future of ultimate high definition, the ultimate ultra high definition television system. And I want to start this presentation back in a little bit of history that what introduced ultra high definition into the marketplace was an ITU specification for color, and all of this, when it came out, caught the production industry totally by surprise. In other words, the sets were on the market before anyone producing content knew that it was going to happen. So this has been a consumer-driven format. This is my first television set. This is the black and white TV set that my first, it's the 1950 Zenith. But I got my start in the days when the television system was a set of hard and fast fixed rules about what we did, because there wasn't a lot of flexibility in what the CRT could do. Therefore, in order to have a communication system, we had to have a system that functioned only one way and could only do one thing. And as you all know, in a communication system, in order to have good communication, it means that all the rules have to be understood. As an example, if I have a fax machine and I'm trying to send a fax to another machine, if the second machine doesn't speak the same language as the first machine, I'm not going to transmit anything. And if, as an example, in language, if someone were to speak French to me, I wouldn't understand anything that's being said, so there would be effectively no communication between someone speaking French and myself. Now, theoretically, if someone speaks English to me, I'm going to understand a lot more about what's going on in the communication. But there can still be variations in the English language for which I don't understand. As an example, when I first went to England to work with a company by the name of Stella Wilcox, engineers dropped me off at the hotel, and they basically said to me, "We'll knock you up at 7:30. And here we go. I understood every single word that was being said and didn't have a clue what they were saying. And what's 7:30? But never mind. But what I'm saying to you is that if you don't, if there is any variation in the rules in any direction, something's going to get lost. And this is a really good example of two people speaking English, and somehow I understood every single word and didn't have a clue what was being said. So part of what I'm trying to tell you is that a communication system is only as good as following the rules. Up to this point, it's been one set of rules. Obviously, they've changed when we went from black to white to color and when we went from standard definition to high definition, but it's always been a known commodity in what we're doing. Now, when we went to flat panel displays had to perform like CRTs because our television system was based on the CRT and what the CRT could do. So any new technology that came out had to look like a CRT and had to act like a CRT in order to conform to the rules of the road in order for communication to take place. So in this particular example, when we were first looking at products, we compared them to a CRT to find out how well they were performing. Now, in the post-production world, we've actually been in the resolution of what is claimed to be 4K. Now, the word that's out there is that the resolution is 4K. And in fact, we've been using the real legitimate 4K in post-production for 21 or 22 years, depending on how you look at it. The 4K system was brought into existence in 1992 by Eastman Kodak at the Cine site for transferring film to video. And they had determined that the resolution of 4096 across the top of the picture was what was necessary in order to resolve the content of a 35 millimeter piece of motion picture film. That's where the 4K format initially came from. Now, the first real use of it was 1993. Snow White and the Seven Dwarfs was scanned. The film, the Technicolor film, was scanned at 4K. It was digitally processed, and then it was scanned back out to film. So the 4K was strictly a digital intermediate, which is an important word because digital intermediate is associated with 4K. So the format itself has been around for quite some time. Snow White and the Seven Dwarfs, the first film to be processed in the digital intermediate mode, the first modern film, and that actually had a 4K master, was Spider-Man 2. So we had been using it to restore films up to that point. In 2008, the 65 millimeter film Baraka, instead of 35, it was shot on 65, it was released on 70. So when I say the 65, it was the 65 negatives that were scanned, not the 70 millimeter print. But anyway, Baraka was done at 8K, because obviously the 65 millimeter negative is much larger, and therefore we want to scan it at a higher resolution. So as of 2008, we have actually been working at 8K. And so here we go with what we're doing today in the system, that we're starting out at the highest resolution. 8K is used for scanning 65 millimeter negative and of course 70 millimeter prints. And right now, instead of doing 35 millimeter at 4K, we're actually doing it at 6K. And that's actually necessary to get a good 4K master. We need to scan it at a much higher resolution than we're distributing. And right now, the scanners for 35, the best they can do is 6K. And then, of course, ideally, we would be archiving these 4K formats. And I've put sometimes afterwards, the big joke of the fact that we've been scanning at 4K for so many years, nobody ever expected it to be used. So things would be scanned at 4K and they would be immediately converted to either 2K or 1080p, and the 4Ks were thrown away. The 4Ks, none of the video processing was done in the 4K domain. It was strictly scanned at 4K, and then that 4K was converted to either 2K or 1080p, and the 4K masters were thrown away. So the reality of our doing 4K for many, many years is very little content exists in that domain, because nobody in the post-production industry actually expected it to be used. So when I say sometimes, there is very little material that's in the 4K domain. Most of the material is in the 2K domain, which is slightly higher in resolution than 1080p, but most of it is in 2K. Many films done today, they may be shot at 4K, but they're down converted to 2K, and then all the special effects are done at 2K, and the master for digital cinema release is a 2K master. So there isn't a lot of 4K content in existence today. Now, film is scanned. This is an ARRI scanner, and film is scanned. Film goes through the scanner. Light comes up through the bottom. But and part of the reason I'm doing this, I went around to post-production houses. It's all 2K. All the processing is done at 2K. Here's an example of 3 different facilities. They're doing all their processing at 2K. So I'm trying to emphasize that even though something might be scanned at 4K, all the processing is being done at 2K. So, but in the era where digital cinema and home distribution was being done, that was all that was necessary. So that's the way things are doing now. Now, the format is marketing driven, as I've already said. Initially, manufacturers were looking for a way of getting you to go to the store and buy new TV sets. And of course, 3D was the step up from HD, and it didn't go very far. And so from 3D, we're trying higher resolution as the next thing to get you to get into the store and buy something new. But it's been clear that resolution alone isn't all that's necessary to make a format. Now, the 2160p format has actually been around for quite some time. It was codified by the International Teleproduction Union in 2008, June of 2008. And in this particular time, the 2160p format was codified and became a viable distribution format, and as well as a format that is much larger, the 4320p format. So these two formats have existed for a number of years in a definition. And of course, in the document, the thing that I'd like to point out, the point of these higher resolutions was a greater immersion, an immersive experience. And with a greater resolution, you can sit closer to the screen and you can feel like you're there. And so in the specification, in the first specification, they talked about the viewing distance for 1080p being 3 times the picture height, the viewing distance for 2160p being 1.5 times the picture height, and here we go with 4320p, and the viewing distance is 3/4 of the picture height. Now, most people that I'm working with today do not want to sit that close to the screen. So we're not confident, as much as we have been told that the 4320 format is going to be coming in Japan in a few years, really soon. The reality is the viewing distance, we're not confident that people want to sit that close to the screen. So I don't know for many reasons how valuable that is going to be, but it is part of what is being proposed for our UHD format. So when we originally said that we were going to do higher resolution in TV sets, we picked the pixel count that is being used in digital cinema. The pixel count in digital cinema for 4K is 4096, and that's where the 4K comes from, is 4096 by 2160. So incidentally, it's a 1.89 aspect ratio. It's a completely different aspect ratio than we've been using in our TV sets now. And of course, the bottleneck became HDMI, that we couldn't get this 4096 by 2160 down an HDMI cable at the various frame rates that we would like to use. And we couldn't get it down there at an RGB signal. There were a whole bunch of complications. So HDMI became the bottleneck, and we switched back to an already existing format, 3840 by 2160. And of course, it has the 178 aspect ratio, which means that there's a very easy up conversion from 1080p. It's just 4 times the resolution. So it fits well into a huge amount of video material that we already have. Now, naming the format 4K was out of the bag, and therefore it is 4K according to most people. And of course, it isn't actually 4K. And because of the discrepancy, the ITU and the Consumer Electronics Association came up with a new name, and they called it ultra high definition. Now, initially, incidentally, that's what it looks like in my living room, for what it's worth. In 2012, they got back together and said, oh, we're going to add some capability to this format to make it completely different and possibly something more enticing to consumers to buy. So we revisited the 2160p format in ITU 2020. Now, I'll let you read the introduction to the format. This is actually, the italics is quoting from the ITU 2020 specification. But basically, they were trying to enhance the viewing experience, but they weren't really telling you how they were going to do that. They just said, it's going to be sort of approximately. That's basically what that says. And the implication, of course, is that we aren't talking about what the actual picture size needs to be or anything like that. The specifications, you recognize the number from the earlier document, same set of numbers, but they did something different here. They changed the color. They changed the primary colors, red, green, and blue. So that became the new thing, that the color capability of the system was going to be better. And they allocated, or they allowed a system so that we can send red, green, and blue down the system. We can send equal bandwidth channels down the system, or we can go to the component system that we have now. And of course, the biggest mistake they made is they included the 420. This is supposed to be a grown-up system, something that's better, but they included the 420, which is what is used for broadcasts now. All of your video that comes over MPEG or whatever comes to you is 420. And it's a form of compression that actually hurts the picture quality. Now the interesting thing is that nobody, I won't say nobody's talking about, but few people are talking about, is the minimum bit depth is 10 bits. Everything we have broadcast today is 8 bits. Does everybody know that? That all the MPEG that comes to you is an 8-bit video. And so among the places where they did step up to the plate is they said it's a minimum of 10 bits, but they also included 12-bit coding because they already knew that digital cinema had done the experiments and found out that if you have an expanded color capability alone, you need more bits in order to get it. So digital cinema today is 12 bits. And there was a clear understanding if they were going to pull this off, we needed more bits in order to convey the information properly. So if we take a quick look at the new color specifications, we look at the CIE diagram. You've all seen this. This is what the color space of 2020 is in specifications. If you look at the numbers that are in the spec, that's where they land on the CIE diagram. So where does it come from? It comes from trying to encompass all surface colors. In other words, make the triangle of red, green, and blue big enough so that any surface colors can be communicated, and therefore we're going to have a system that will convey many more colors than could be conveyed ordinarily. Now, I don't know how many of you are even old enough to remember Rinso detergent. Rinso detergent had waves on it that were green and cyan. The green nor the cyan could be communicated in the television system because our colors, well, this is the original 1953 color system, and this was our current color system. And in our current color system, the green and cyan were completely cut off. So Rinso detergent couldn't properly advertise on television. And of course, if you've ever gone to art school, they will tell you there are certain colors you can't use in a logo. The reason you can't use them is because if you're going to advertise your product, no one will ever see your colors. Now, the interesting thing to me is I've actually had to go to colleges and explain to them why you can't use those colors. That no one says, this is the reason you can't use the colors. They just say, don't use them. And I find that really amusing. But that was a limitation of the CRT. It was a limitation of our television system. We couldn't do better and still have an affordable system. Nowadays, incidentally, this is the three systems, EBU, HD, and SMPTC. Nowadays, of course, with new display technologies, we have capabilities well beyond anything the CRT could ever have thought of doing. So there's lots of triangles out there now. And some of these triangles are taking the F65 as a camera, and that triangle shows the color gamut that the F65 can capture. There's another one for an F35. There's another one for print film. There's another one for DCI, digital cinema. That's the color space that is used in the digital cinema. And then the smallest triangle, of course, is our television system. And so there is a desire to have a bigger system. Now, if you think those weren't enough triangles, there are many more. I just want you to know that those aren't the only triangles that are out there. Now, today, when we produce content, we produce it in a color space that is called CapXYZ. You can see it in the green, and you can see that it is, the CapXYZ is very much larger than our color space. So why would anybody want to produce in a space that's very much larger than anything anybody can see? The reason for that is that CapXYZ is not a color space, it's a carrier. This is an important concept to the future of our television system. that, and I'm borrowing from Mike Heiss because I actually like his analogy. I used to use multiplying two 10-bit words, or two words and having to have more digits if you start multiplying. But if you process, his analogy of this is if you have a full container of orange juice and you want to shake it up. Do you know how hard it is to shake up orange juice when the container is full? Do you know how easy it is to shake up orange juice when the container is only half full? In other words, if you want to mix something, if you leave room to mix it, it's easy to mix and you lose nothing. But if you have a container that's so tight and you want to mix something, it's actually difficult to mix it. So what we did in creating a standard for producing content, we now carry our content in a large container. So no matter what we want to do with it down along the line, there is space in that container to do it without losing anything. Does that make any sense to all of you? So we make the carrier very much larger than anything we want to display, and then that way we lose nothing in the process. So 5 years from now, if you want to go back and you want to do something with it,